Okay, let's have a very good look at something called dimension analysis. During the dimension analysis, we can find out unknown physical quantities in a certain dimension. So formula, that means first we can find out the physical quantity in SI units as well as the dimension of it. So let's just have a good look at. So you can do it just by simplifying in the normal mathematical way, like subjecting the stuff and substituting the known values to the other parameters. But it's not gonna work in every time. So let's have a very simple example firstly. I'm going to take a very small formula, that means a very normal formula, common one. You will come across this one within 1 year or 1.5 years according to the teacher. So this is what Newton's law of universal gravitation, right? According to that one, so the force of the gravitational attraction between two objects is proportional to masses, magnitudes of masses, and inversely proportional to the distance between them, the square of distance between them. And in that term, we don't want to go that extent. I'm just explaining about this one, and you will just find it. And for this, we just need the equation and the known values, known parameters. So for the F, it is a force. We know what is force. It is mL t minus 2. And for the mass, it is capital M. And for the length, radius is a length. So because I took it as a radius because the planets are revolving around a certain this type of what? Circular path. Even though it doesn't revolve around a circular path, just the distance between them is taken as the radius between them. So in that sense, it's a length. So now we have three different parameters. Now I need to simply subject the unknown factor about G. This is an unknown thing, and we don't know the dimensions of this one. And we know the dimensions of these things. Now, how to look at? How to find out the dimension? So firstly, I need to rearrange the formula and subject what I need. Here, I'll get it like FR square over Mn, simple M. So now I'm just going to substitute the values and find out the answer. So substituting the value for force is mL t minus 2, and the R again L to the power 2, and divide this by M by M. So I'll write it like that rather than writing M square. So you can find very simply cutting it off, and the final answer is going to be, I'm writing it here, and that's going to be M minus 1 L to the power 3 and T to the power minus 2. So this is how we can find. This is valid for this type of equations. There are some other equations, they are no longer valid within this method, and we have to apply certain laws of dimension rather than laws of mathematics in those cases. And here there's an equation. This is kind of weird one. Why? It has some addition and division, and in the division even there are some addition in things, and it looks like a very complicated one. For tackling these type of complicated things, the mathematical laws are no longer going to be valid. Now think about if someone tries it like this way to find out. Here's how you would look at. If someone just try to find it out like this way, subject in T1, it's going to be, someone might do it, V minus K3 times T to the power 2, and he would multiply this by using K2 and plus T. So, it's very weird. So, you will get the answer like K1 is that dimensions of K1. Can you? No. Very big wrong. Why? It is, I told you, it's no longer mathematically valid. It's just not the mathematics. Now here are some laws of dimension. According to the dimension laws, the similar dimensions other things can be added. So after applying any plus or minus thing, the dimensional is no longer going to be added. So valid. So we can treat them individually. That's the point. this is a very wrong way to apply. Don't do that. And I have seen many of my students even trying to do that. When first time I give these type of calculations without I assisting them, I ask them to find out. So they apply their mathematical rules all the time and they get no answer because there are 3 unknown variables. How come you find? No. Right? Only one unknown variable at a time we can find out. So remember, mathematical rules are not the thing. Here just a simple dimensional rules in physics. Have a good look at now. As I told you, we can separate them according to the rule of dimension because the similar dimensions can be added together. Which one out of these things can be found easily? Some may say K1, K2 or K3. For K1 it's impossible because it cannot be done. So let me separate them. The first thing is first. So V, dimension of V should be equals to dimension all together. That means K1 over K2 plus T plus K3 and T to the power 2. But as this is according to the rule of left hand side should be equals to the right hand side. And furthermore, I told you that similar parameters can be added in physical dimensionally. Two different things can be added. So one in that case, so I can separate them again here. K1 over K2 plus T of dimension of that one because it's in addition. So I can separate them. And again, K3 and T to the power 2, I separate them. Now you can treat them individually and equal to each any of these things. This is the way, not that way. Now have a good look at how to find out the dimension of any of these. According to this way, somebody might say K3 is the easiest. But I say, no, not the K3 is the easiest. I say K2 is the easiest. How? The rule, again, the similar dimensions can only be added. That's in that way, if x plus y, the dimension of x should be equals to dimension of y. That is the rule I'm going to apply over here. Same rule applying here. Very simple. According to that rule, I can write dimension of K2 should be equals to the dimension of T. So dimension of T is nothing other than time. So dimension of K2 is going to be capital T. I found that. Now the second one. I can use the same rule to find out K3. Now I have to erase this part. And K3 dimension of V should be equals to the dimension of K3 and T to the power 2. So V is LT minus 1. That should be equals to K3 and T to the power 2. K3 is going to be LT minus 3. Dimension of K3. This is very simple. Now I have found K3 even. Now I'm going to go for find out K1. I told you K2 and T have the same dimension, so all the denominator becomes T, dimension of capital T. So it's going to be very easy now. Life is going to be easy over here. So V is going to be equals to K1 over just T. Now I can neglect any of this because just one dimension out of it. K1, dimension of K1 is going to be LT minus 1 times capital T because velocity dimension has the dimension of LT minus 1. And K1 is nothing other than L. It's very simple, isn't that? Now let's have a look at about something little bit advanced. Little bit, just bit, but it has nothing. Even though the equation looks very bigger. Now again something, this is a very real popular formula while computing the dimension analysis thing. According to this formula, I and I naught are just currents and capital T is time and K is a certain dimension we don't know and A and B are also certain dimensions, I need the dimension of all three together, K, A, B. And now C is a dimensionless thing. Now there's a big problem. How the heck can I just solve this and get the answers? Very simple. According to one of the rules, dimensions of any logarithmic value has no dimension. That's one theory. So I can cut it off, and this one also can cut off because dimensionless thing. And in another way also, if you can add something with another thing, as I said you, x plus y, that should be dimension of x should be equals to dimension of y. So in the case of this one, this is dimensionless thing. Dimensionless thing can only be added with dimensionless thing. But another logic to get the answer, if you get this in this logic even, this becomes 1. If you add something to 1, this should be also 1, otherwise no different things can be added. So whole lot of this side is going to be vanished. Now it is going to be just 1. Very simple, no? As it, even though it looks very complicated, doesn't matter. Now have a very good look at. Now left hand side, all of just become 1 and K over T over AB. What you need is subject is K over AB. Now I'm going to separate them. K over AB times T, and you need to get value for T. Sorry, K over AB. K over AB, dimension of K over AB is in a square bracket, is 1 over T. That is nothing other than T to the power minus 1. This is the dimension of frequency, or in another way, this is the dimension of angular velocity. So, two different physical quantities, but having the same physical dimension. So this is how you are just going to tackle any of these things. And just keep in mind, when you find any sine, cos, tan, any trigonometric ratio, the value is going to be 1. Any x to the power n, that means anything, it can be like e to the power minus 5 over t, whatever. So, doesn't matter, right? Anything it can be, the index should be 1. Dimensional value. Any index or logarithm value, whatever it is, or just a number, so 6 pi, whatever, just a number. Whatever this type of constant thing without dimension, they are treated to be dimensionless. This is the rule that you have to follow. Tackling any of these dimensional questions rather than considering all the mathematical things, this is very simple. If you consider the thing using your previous mathematical knowledge only, you will find so much of difficulty. But you need some basic mathematics. This is also from mathematics. That's why you can understand e to the power x something is just a number. But remember, physical rules is all depending on with the physical rules. And in the next week, we are going to learn about very new chapter that is going to be measuring instruments. That is, I'm going to start that on Thursday. So get ready for that. That is very important thing rather than the lessons we did so far. Because for these lessons, you will find very small amount of marks, somewhere around 1 or 2 to maximum 3 marks. But in the terms of the next lesson, it has a lot of marks, something like it can all come up with a certain bigger structured question, or sometimes it may comes up with some structured question and some 2 to 3 MCQs, so we can expect somewhere around 8 to 10 marks. So get ready for that. It's really important.